and welcome back to Cool Chemistry with Miss Kiernan. We are going to spend today talking about our compounds because we're going to stop moving forward in our curriculum. We're actually going to take a step back and start reviewing for our comps. So our comps are still coming even though we're at home. So I just want to do what I can to make sure we're all prepared and we're all going to do as fantastic as I know all of you can. So like I said, today we're going to start reviewing our compounds. We're going to review what is, I think, one of the hardest parts of our compounds, our binary 2 compounds. Our binary 2 compounds, if you remember, that's when we have those parentheses where we're not quite sure exactly what goes inside of it. And so today we're going to clear that up and we're all going to know that by the end of this, what goes inside those parentheses? Charge. So our charge is going to go inside that parentheses, and today we'll talk about how to figure that out and exactly what we're going to do when we're naming these. So that's what we're going to learn this week. That's what our homework is going to be on, and then hopefully we'll know exactly what we need for our test at the end of the year. So let's get into it. Okay, so if we're going to talk about our binary 1 and binary 2, the first thing you have to do is be able to figure out what is a binary 1 and what is a binary 2. We can always identify what type of compound we have based on its metal. So binary 1, we can identify compound based on its metal. And its metal is when we have something in group 1A, 2A, or that triangle. Remember that our triangle is silver, zinc, cadmium, aluminum, gallium, and indium. Those are our 6 elements that we're going to call our triangle, and it's going to be included in that binary 1 category. Our binary 2 compounds, again, we can identify based on its metal. So our binary 2 compounds, we're looking for a metal that's really just anywhere else. They're metals that are not in group 1A, not in group 2A, and not in the triangle. So if we look at our table, our binary 2 metals are what really make up most of our table. So now that we know how to identify our binary 1 versus our binary 2 compounds, we're going to figure out for our binary 2, how exactly do we name those? And what do all the parts of that name mean? So our binary 2 ionic compounds, the metal element in our binary 2 ionic compound can have multiple possible charges. And this is our transition metals and sometimes those post-transition metals right to the side of that. Our transition metals, they can have multiple charges, meaning that we can have iron with a +2 charge or iron with a +1 charge. And so the reason why we have to be so specific with our binary 2 compounds is because we need to tell people exactly what charge we have on that metal. The way that we're going to write this down is by adding our parentheses. So our parentheses are telling us the value of the positive charge on that metal. So we're always going to write the metal with the charge in parentheses. Down here we see our example of iron 2 sulfide. That's telling us that our iron has a +2 charge and it is bonded to our sulfur. So now we have to go through and we're going to figure out, well, how do we know what the charge is? When we're writing these names, the way that we're going to determine the positive charge is through our backwards drop charge method. Our first step is we're going to write our compound and we're going to pull those subscripts up and back across to become charges again. So here I have my compound V2O3. I'm going to take those subscripts, that 2 and that 3, and I'm going to bring them up and across in order to make them into charges again. So I'm bringing my 3 up to vanadium, bringing my 2 up to oxygen. Now that I've brought my subscripts up and across, I have my oxygen with a -2 charge, and we know it's negative because it's a non-metal. Our non-metals are always going to be negative, and our metals, our vanadium, is a +3 because we know our metals are always positive. So now that I have my 2 charges, my next step is to verify the charges on the non-metal. So what I'm going to do is I'm going to look at that oxygen and see, is that the correct charge on oxygen or do we need to change it? So we're double checking this oxygen to figure out, is this the correct charge? This is the correct charge on oxygen, which tells us that this is the correct charge on our non-metal, and our metal is also going to have the correct charge. So now our vanadium and our oxygen are both correct. So now we can move on and we can find our name. So when we're thinking about what's inside that parentheses, we're looking at the charge. So when I finalize this name, we have vanadium 3 oxide, and I'm getting that 3 from the charge on. There's also a possibility that the nonmetal won't have the right charge. And if our nonmetal doesn't have the right charge, oxygen had a different charge, a -2, then that means we have to go through a little bit more work to figure it out. So we're going to multiply both sides by the same number in order to get our correct charge. I'll show you that next with our iron sulfide. Then after we find the correct charge on the metal, again, we're using that charge in our parentheses in our name. Let's try that out. Here we're going to write the name for iron something sulfide. So we have our compound FeS2. The first step, I'm going to take these numbers and bring them up to become. So I have iron with a +2 charge, and then I have sulfur with a -1 charge. So here, the way I got that 1 is because we know that if there's nothing written for our subscript, we're going to assume that it's a 1. What we do is we're going to figure out, well, is that the correct charge for sulfur? No, this is not the correct charge for sulfur. Sulfur is supposed to have a -2 charge. We're going to multiply both sides by 2. So now that we've multiplied both sides by 2, our charges are Fe with a +4 and sulfur with a -2. So again, we're going to check, is this the correct charge for sulfur? Is sulfur supposed to have a -2? And the answer is yes. Sulfur is supposed to have a -2 charge, which tells us that sulfur is correct and iron is correct. So now when we go to write the name, we just have to figure out what to put inside those parentheses, and we're going to take the charge on that metal and put it in. So I've put my parentheses 4, and I'm using Roman numerals for my number. So those are the 2 cases we're going to see when we are writing our names for binary 2 compounds. Those are 2 things you have to really pay attention to, is what is the charge on that non-metal in order to make sure that you're getting the right charge for your metal. Now that I've shown you some, it's time for you to practice on your own. In your notebook, please try these 6 problems. Make sure you have the correct names for each of them. Pause the video so you can do this, and then after you're done, unpause this video and we'll go over the answers. So pause it now. All right, here come our answers. So here we have the answers to our 6 problems. In all of these, we notice that they all have those parentheses. That is something that is integral to our binary 2 compounds. We have to have those parentheses, and then it's up to us to figure out what numbers go inside of those parentheses. So we have to figure out, again, using that backwards drop charge method, where we're bringing our subscripts up to charges. Then we're checking our non-metal, and if our non-metal is incorrect, we're multiplying both sides by the same number to get to our answer. All right, so that is our first stop on our review bus as we go to our comps. We are working hard to make sure that everybody is as prepared as possible, but remember, if you ever have any questions, you can always message me. I am always here to help you in whatever ways I can, so just feel free to reach out. Other than that, I'll see you next time.